Next, we have, now we're starting the heat of fusion section. So this is where I have my rounded values, and so the mass of the water is just going to be the difference, like before, 50 grams. Okay? And the mass of the ice is also going to be a simple difference. We have the mass of the calorimeter and the water and the ice. We subtract that from the calorimeter and the warm water, not the temperature, but the mass of the calorimeter and the water is 100 from 150 leaves us with 50. Oop, okay, so there we go. Now we have the heat lost by the warm water. Okay, so the heat lost by the warm water, if you look at the notes that I sent, again, whenever we're finding that heat, you're thinking Q equals MC delta T, and this is heat lost. So we know we're going to have a negative value. We can just put that in to begin with. All right, as a reminder. Now, so Q equals MC delta T for the warm water. All right. So let's see what we get here. Q equals MC delta T. What is our mass for the warm water? Our mass of the water, we said, was 50 degrees. Okay, so that I'm sorry, 50 grams was the mass of the warm water. All right, so there's 50 grams, and then the specific heat for the water is 4.184 joules per gram degree Celsius. The change in temperature, we had the change in temperature, we can determine that from the temperature rise of the system. It ends up being 25 degrees at the end, and it started out at 100 degrees. Okay, so a difference of 75 degrees, and it's actually dropping in temperature. So final minus initial ends up being a negative 75 degrees C. All right, and so Q equals mass times the specific heat times the change in temperature. Okay, and so here we have the heat lost from the warm water is 15,690 or 15,700. Okay. 22, the temperature change in degrees C of the ice as it changes to water and then warms up to the final temperature of the system. So the ice is starting out 0 degrees, warming up to 25 degrees, so its temperature change is 25 degrees. Okay, the heat in joules, again, this time gained by the water, so it's going to be positive, and the water being the melted ice, so not the warm water, but gained by the melting ice as it warms to the temperature of the system. Okay, so Q equals MC delta T. This time I'm using values for the melted ice water. Okay, so I had 50 grams of that water, just like before. In fact, the only thing different, since it's still, we're looking at the liquid water, so it's still 4.184, and This was in joules. And so we have the mass times the specific heat times the change in temperature for the ice, which was it was increasing in temperature by 25 degrees. Okay, so we have 5230 joules. Okay, so now the heat of fusion. Okay, remember, heat of fusion is the heat that is required to melt the ice. Okay, it's the heat required to accomplish that transition. So the ice is absorbing heat to melt it, and then it also warms up, in this example, to 25 degrees. Okay, so so the heat lost by the warm water is going into two places. First, it's going into melting the ice. That's the heat of fusion. And then above and beyond that is what is going to, the amount of heat going to warm that melted ice water. Okay? So, so what we have, if we look over here, here's the amount of heat lost by the warm water. All of that heat went into melting the ice, and then this amount went into warming the ice. Okay, so you can see from these values about 10,000 joules went into melting the ice. Okay, so specifically, since now this is where you have to pay attention to the signs. You have to think about what's happening. I'm losing this heat, and I'm gaining this heat. But when I'm doing this in the calculation, I'm just going to use the positive values there. So what I'll have here is I'll use a positive 15,690, and then minus the 5230, and that will give me the portion that is gained by the ice to melt it. So this many joules is to melt the ice. Okay, that is the heat of fusion. Okay, now I can't put that number in there directly because it's asking for it in joules per gram. Okay, so I need to divide that by the mass of the ice. That's the heat that was required to melt the ice, but it was required to melt 50 grams of ice. So I take that value, divide it by my 50 grams, and that is my joules per gram, the heat of fusion for the ice, 209.2. Okay, and that will be positive. Okay.